Hello, good afternoon, everyone. We welcome you to the webinar on model-based workflow of brake systems engineering, organized by collaboration in between Dassault Systems and EDS Technologies Private Limited. I'm your host, Omkar Madekar. I work here as an application engineer. We have Mr. Prakash Pagdala, who works as an industry process consultant for the customer process experience at Dassault Systems India. I'll just introduce him and I'll hand it over to Mr. Prakash so that he'll take it up from the point. So Mr. Prakash is a industry process consultant at Dassault Systems India, working with similar team from Jan 2019. He has various domains expertise, which includes process automation, customization, fatigue simulation, automotive engine and power durability, and many more. He has touched various clients from life sciences, transportation and mobility, tire and industrial equipment segments. Prior to joining Dassault Systems, he was with Alter Engineering India Private Limited for around 6 years. He completed his BTech in mechanical engineering, and he completed his master's in design engineering. So we request all the participants to be muted throughout the webinar. And if you have any questions, you can drop them in the chat box. Otherwise, we will take it up after the webinar. Prakash, I request you to take it up from this point.
Yeah, thank you very much, Shankar. Thank you for introducing me to the audience. And hello, everybody. Good afternoon. I'm Prakash, and today I'm going to discuss on what we call as industry process experiences. One of them is the brake system engineering industry process experience with you. Now, so since you've been working on brakes, and you know better than me on brakes, so we all know that brakes on any vehicle what it does. So they are useful to slow down or stop the vehicle at a safer distance. This makes them a very critical entity in any vehicle, not just in passenger cars, but also in our other commercial vehicles as well. Brake systems, as I've said, is a critical part of vehicle architecture, and designing a brake means you're avoiding a catastrophe and providing a stable ride experience for if it is a passenger car or depending on whatever vehicle it is. A good brake system design will ensure reliability, durability, efficiency, performance, and safety. And however the vehicle, wherever and however the vehicle is operated at different speeds or different torques, etc. Now, when the brake design is inadequate, the vehicle performance can be poor, and also it can become unsafe as well to those who are driving. Now, before we jump into the core part of it, let's understand what are the industry trends, what we have, the recent developments in the automotive industry or transport and mobility industries. With regards to the business drivers that are affecting the transport and mobility industry, brake system engineering it has to evolve to answer the global mega trends with respect to the electric and the connected vehicles, with respect to the customer experiences, and with respect to the customization of it, etc. When it comes to electric vehicles, now there's a lot of buzz about range and all, and we have been seeing a lot of RBS, regenerative braking system for efficiency or the range. So new regenerative brake systems are needed to meet efficiency and range test. So brake system needs to be integrated into these new vehicle architectures. And so if you have adequate, good braking system, which will improve your range, then the chances of selling your product in the market are pretty huge. And also when it comes to increasing the efficiency, the brake system plays a major role in with respect to the efficiency and the range. So brake system, like the airflow that's used to cool brakes will have to be carefully managed, as it can affect your vehicle range. And with respect to competing demand for maintaining quality and while reducing and meeting the regulations, our brake system need to be designed better, better brakes, faster, that have a predictable in-service maintenance needs. Uh, and with respect to customer experiences, you should provide. When a customer is purchasing a vehicle, they'll look at comfort, and brakes can become a contributor for the disturbances, the noises, the vibrations that are causing because of bad brake systems. So brakes must not contribute to any such annoyances such as noise, and it should work well most of the times, or 100% of the times. Now we have been moving from a mass production from we are moving from a mass production to a mass customization, which means you have a lot of uh, segments of a vehicle, like the hatchback, sedans, SUVs, and each has their own its own parameters to address, and that each has its own operating parameters, and these brakes, the design need to serve these, should fulfill these parameters, where different parameters need different attention. So OEMs and suppliers must work together to design in tandem to design and integrate brake systems into vehicles while reducing the potential issues and costs as well. So now, if we look at the challenges, I'm not going through all the challenges, but these are some of the critical challenges which we think uh, which are faced by most of these uh, OEMs or suppliers, which is the first one is your physical test. Physical testing is limited. We do have a lot of lab tests, of course. We do a lot of lab tests for most of these automotive components or aerospace components. Every component undergoes a lab test, but that is not alone is sufficient. When these components are integrated on a vehicle, they can be a lot different in real conditions. Maybe you may not be able to represent the real conditions in the lab, and it is also not possible to capture all the data in a lab test, which is where we lose some critical information. And this is why simulation plays a major role in understanding uh, something, the data, what the critical data which may not be available from our lab tests. And of course, the physical tests are expensive at the end of the day. Through simulation, again, it is possible to avoid over designing, which again may not be nowadays the over designing is pretty rampant, and this can be addressed through simulation at the very early stages of designing, uh, which again may not be possible through physical tests. Frequent braking in long travels or in city driving conditions puts a lot of heat on the brakes, which affects the range of or efficiency or performance of the brakes. Vehicle drag and lift that can happen because of the aerodynamics of the vehicle itself, that will affect the performance of the vehicle, and also the ride comfort of the driver or the passengers. So the way the brakes are put up, the wheel rim, etc., everything contributes to the performance. So it is important to understand how cooling is vented out, or how the brakes are cooled. So cooling vents can affect the performance of the brakes, and how safe they are. So this all affects on the cooling of the brakes as well. Next, we talk about the customer expectation, which is the major issue is noise. So in order to meet customer expectations from a brand perspective or from a supply perspective, brake systems also need to be addressed a lot, a number of other potential issues. For example, any brake noise can cause a lot of annoyance to the driver or the passenger, which will create a bad brand name. So if you have a better braking system which eliminates most of the noise, will stand out in the market. So brakes must perform in realistic road conditions with dust and soiling. Also, brakes must follow a predictable maintenance schedule. So dust and soiling can also reduce your range, your vehicle range or the efficiency, and also could heat up your brakes. So this also plays a major challenging threat uh, in the industry. The problem for a brake manufacturer is basically uh, given here. It's in the slide. So there are different domains and disciplines involved. There are design aspects, there are integration aspects, multi-physics aspects, etc. So in the traditional engineering approach, each engineering team finds the best design working in isolation. And if we can integrate these processes, that can lead to a better optimized product and within a reduced time frame. So it is when these engineers are working isolated, it is pretty difficult to find a final optimized design. So if you collaborate everything, if you integrate everything, the integration part, the design part, and the multi-physics part, if you integrate everything and if you bring everything together on a single platform, then the chances of having a better product at a better time is possible. So at a process level, what we have to offer the solutions that can cater to various aspects of engineering of a brake system. So we are talking about the brake system design as well as the brake system performance, the two different aspects. But uh, being a simulation engineer, my focus will be more on the brake system performance. So if you look at the slide here, there are a lot of workflows available on this, like the vane flow performance, the brake thermal stress simulations, brake cool down, brake squeal, groan analysis, brake integration into the complete vehicle architecture, brake duty cycle and wear of it, brake soiling, brake durability, and the system performance. All these are addressed with different physics. Like for example, the brake thermal stress, the brake soiling, it's through CFD. The brake cool down is again from CFD. And the brake squeal brake gone from structural simulations, and the sensor performance are from Emacs simulations. These are completely different physics, and if you could uh, try to integrate this onto a single platform, then you have a complete package of understanding your product, and you can analyze your product in a better way. So with brake systems engineer industry process experience, engineers can improve braking margin by simulating the entire system. And today, to address these, there are many workflows like what you're seeing on the screen. And this can be addressed instead of in working in silos. We can bring together everything. So from through brake systems engineering IP, we offer uh, what we offer allows engineers to digitally design brake systems for real world performance. So now let's look at the benefits of the brake systems engineering IP. So with the brake systems IP, engineers can improve the braking margin by simulating the entire vehicle system with a systems modeling solution, which can help to understand the braking margins at different speeds and at different conditions, which will help you further. The data what you acquire from these will help you to further optimize your brake uh, and provide a better and a safer uh, braking system. Braking margins should also work in wet conditions. Uh, Again, there are certain challenges when you're working, when you're designing the brakes in the labs. You have a certain restrictions. You cannot have uh, a wet conditioned lab. Nowadays, most of the customers or the brake manufacturers are currently using climatic tunnel testing with UV dyes, which again doesn't provide a closer insight of what exactly happening inside the system. So there are certain challenges like uh, measuring the wetting film, what is the thickness of the film which is going on during the wet conditions during operations, and long cycle testing. Again, this limits your design evaluations. The cost included for testing, like if you're doing a tunnel testing or climatic tunnel testing, the high costs are involved in this, and these tests does not uh, reproduce your real world road conditions or airflow conditions. So you have a restricted environment for testing. Again, the dirt, rock, and mud, these are not allowed, which may damage the tunnel. So you're not taking these into the considerations, and any late stage discoveries because of this can become another challenge for the brake designers. So if you're this whatever the simulation what you're seeing on the screen is done on one of our CFD solvers. Uh, if you do the same through a simulation, you can visualize the water flow onto the brakes, how the water is been flowing, and accordingly you can change your rims dimensions or the guards accordingly, or the wheel dimensions accordingly through a simulation. You can find the sources and design shielding. You can shield accordingly to reduce the splash of water coming onto the brakes, which may reduce the efficiency of your system. Discover issues, instead of discovering at the very late stage or the during the production or the prototyping stage. Uh, you can discover these issues at the very beginning of before prototyping through simulation. And again, you're eliminating the entire climate tunnel testing, which is a lot of cost saving at the end of the day. So you can also include uh, soil, mud, dirt, and rock, etc., without risking your equipments. So you can investigate the effects of these as well uh, for your brake systems. Virtual testing on digital mockup also helps improve the efficiency and range by reducing drag caused by brake cooling airflow. So if you're minimizing the drag penalty due to the flow through brake cooling techs, can reduce the mass of it. That will help you to reduce the mass of the brake rotors or the brake pads with sufficient cooling. Also, early stage digital prototyping enables more efficient, cost-effective design exploration, and help avoid the late stage failures like overheating of the brake systems, boiling of uh, brake fluids, cracking of brake rotors, etc. This can all this can also be addressed through the simulations. And again, the passenger experience, you can by eliminating brake noise, you are able to you can provide a better. I don't know if you're able to. I don't think you can hear the sound coming from this squeal, the noise, due to the brake squeal, uh, which is kind of annoying to any passenger or any driver. So if you eliminate the brake noise issues like the squeal and groan, then that's a great improvement you have done on your brakes. Another benefit is the brake warranty costs. These can be reduced by predicting in-service brake duty cycles. So duty cycles is basically um, how your brake is operating over a period of time. So vehicle um, may accelerate and decelerate through brake for a number of times in its lifetime for different speeds, different uh, torques, etc. This can help capture. This can be captured through the brake duty cycle, and this can be used to improve the brakes, the braking system as together, and also the brake cool down temperature and brake wear can be predicted through the simulations. And for if you're designing brakes for aggressive braking performance on test track, for example, a virtual validation approach can um, this can test entire drive cycle digitally, allowing racing team, or if you're designing your brakes for any racing team, they can excel in this you know performance. They can provide a better performance with the vehicles. So this is a video on reducing the mass and improving the strength, stiffness, and durability, and maximize the cooling. So using this industry process experience, engineers can also reduce mass, improve strength, stiffness, and durability while maximizing the cooling. In this example, a maximum cooling by 10 to 20% is achieved, more than 20% is achieved, and the mass has been reduced by around 25%, and the peak stresses have been brought down by 20%. So if you see here, a complete workflow has been, you can see automated here, starting from parametric designing of it, parametric optimization of it, and understanding the fatigue of it, the life of it, and redesigning your brakes accordingly for a better life, and also a non-parametric optimization to minimize the weight here, and everything has been validated. There's a complete workflow which is available, which will help you to reduce the mass of your brakes, improve the strength and durability, and also improve your cooling performance. Designing brakes, as we saw before, involves a lot of effort of many engineering teams, each addressing different design aspect from their specific disciplines and disciplines perspective. And if you have a common digital mock-up for brake system and entire vehicle, so these engineering teams can now collaborate and find a best brake system design across disciplines. Again, lab test cost can be significantly reduced by simulating performance in real world conditions, like what you're seeing here, where you're trying to understand the heat dissipation, or when you have how the heat has been dissipated for different speeds. And you can compare to labs. You can actually get unlimited data. You can capture a lot of data, and you can improve your designs accordingly. So with digital continuity and enabling collaboration through a model-based approach on a single platform, instead of the traditional approach where various engineering teams collaborate through emails or through phone calls, and often rely on a data translation in a file-based PLM approach. We offer a platform which offers seamless connectivity across all disciplines, whether it is CAD, CAE, or PLM. Our users can all work on same data set in real time, and CAE teams especially can work on validating designs in a digital environment. And also all disciplines now see same digital mockup of brake system and vehicle. So this improves the productivity significantly and eliminates a lot of uh, you know to and fro communications, which again improves your productivity and eliminates any non-value added task. So engineering teams and program managers can also manage the entire life cycle of product, all the way from requirements to complete validation. Uh, in a particular customer example for here of a brake squeal steady or on the platform, the design validation can be efficiently and significantly increased by eliminating all not not so value adding task works and implement an automated workflows. Through this, we you can also automate certain processes, and accordingly you can define the KPIs. So this is a sample workflow of the structural durability of what I was talking about. This workflow, which has been existing for a long time, that helps you to reduce the weight and improve the durability and fatigue life of your brake disc, for example. Here you need the vehicle, you may not the vehicle, but the brake system geometries and certain mass and materials of it. In this workflow, we analyze for the life using our fatigue solver or through durability analysis and using the load history, and we do a shape optimization to ease out the stress from critical hotspots, which will improve the structural integrity with our non-parametric optimization algorithm called Tosca. Uh, then we do a parametric optimization study, which will help you to improve your cooling performance without affecting your braking performance, and explore new design alternatives. Also, at the end, you do a structural analysis to validate your design and assess for any durability and wear. So this all entire workflow has been automated both on our established products as well as on the platform. So you have a single platform where you can uh, automate the entire process, and you can share with your other teams where they further do any other simulations like the cooling simulations or any soil dust and soiling simulations or any airflow simulations, etc. So a single source is required. All is required. All you need is a single source, and any modifications will be automatically reflected, and they can be visualize the new changes. This is one more example of a brake duty cycle, and where uh, through our CFD solver, where the complete vehicle is integrated along with the brake system, and the heating and cooling uh, plots of the brakes at different speeds are taken, and the same has been transferred to a transient solver for thermal behavior and has been post-processed. So this is all automated. Again, the workflow has been automated, and with minimal user intervention, everything will the data is taken from one solver to the other solver on a single platform. Here is a list of uh, uh, selected publications on brake system engineering, and some of the papers which are already published, partnering with OEMs, which are indicated again here. I just want to show you these. Um, uh, this is what we call as the ID card for brake systems, which gives a complete overview of what we have been discussed so far. So the objective of this brake system engineering IP is to optimize your braking system structurally as well as thermally, and also to reduce, optimize it for noise performances, and design a better cooling system for your brakes for which improves your thermal management without compromising at the aerodynamic efficiencies, and also predict the temperature for critical conditions and critical brake parts at different conditions in real world operations. uh, the challenges are again, it includes both geo and non-geo challenges with respect to this. So when it comes to geo challenges, it could be the regulations coming from your local geos, governments, etc. Uh, or it could be something related to your design itself. So brake system, you can downsize production, or depending on, and also the mass customization depending on, as I've said earlier, we have been moving from a mass production to mass customization. So that will also affect your, that will also pose as a challenge. And OEMs need to design efficient systems, brake systems, and safe brake systems with uh, very minimizing the durability issues with respect to the life of it, as well as also you have to make it safer. Also include a longer life for the brake systems or the brake test, for example. And whatever the design changes you do should improve the efficiency and should not result in poor particle or dirt or soiling performance, uh, which will which doesn't look good for a customer, and repeated maintenances may be required in order to improve this. Again, that will again reduce the market. So design challenges for improved brake efficiency should not result in the noise issues. So noise again is one other critical comfort uh, a domain for any for any customer. So if your brake system or brake are making any noise when it is integrated on the vehicle, so that doesn't look good at all. So uh, you have to design your brakes accordingly to reduce the noise. Uh, the benefits are depends again, what exactly your challenges are. Based on that, you can either improve your vehicle fuel efficiency by managing better aerodynamics and thermal as well as noise performances. Uh, Improve your structural reliability by keeping the critical brake components under with better thermal management under certain temperatures and stresses during your complete drive cycle. And assess your brakes for different conditions, like dynamical or aerothermal simulations. That will give you a better insight of the brakes and helps you design a better braking system. And also at the end of the day, again, validating before prototype will this saves a lot of cost, instead of identifying late stage problems which may arise some design changes or recalling your vehicles or the products at a later stage. This will improve your time to market and keeps you in a better place in the market, and reduces your warranty costs as well. So now if we look at the challenges or the KPIs, if we segregate as a brake performance KPIs and the business KPIs, so your business KPIs again depends on your product performance KPIs. If you are able to improve your product, uh, if you're creating efficient product, if you're able to create a safer product, and if you're able to get better product, that will uh, improve your business key performance indicators, which will help you to reach the market in time. That will improve your that will have a better visibility, that will create a better visibility for you in the market, and also keeps a good position for you in the market. So through technology values like simulation ready models at we offer the simulation ready models at various scales and fidelity, and a seamless collaboration of uh, collaborated workflows between the engineering teams and also between the suppliers and OEMs, and automated process automation between design and validation helps you to improve your uh, products at design stage and as well as at a simulation stage. That will again help you create a better market in your in your segment of uh, transport and mobility. So we have several workflows which are already available, like like what we have discussed earlier, like starting from brake cool down simulations, brake structural durability, brake duty cycle and wear, uh, brake soiling, venting, vent flow analysis is also available, brake squeal with respect, these are all with respect to structural and thermal simulations, but again, we do also have uh, uh, workflows on, the sensors, understanding the sensors, etc. These are all available as a part of the brake system IP, uh, and like the sensor performance, vane flow performance, brake thermal stress, etc., brake groan, brake squeal, everything is part of this IP. And also the brake system integration with system modeling application is also a part of this IP. So that's all I have to present.
I'll just wind up the session through some of the points I think what Prakash has come up with. So firstly, I think he talked about industry trends from EV segment to its regenerative braking system and how operating parameters of brake systems for OEMs and suppliers. What are the challenges they faced, maybe from noise issues to dust and soiling, and how it is affecting the maybe efficiency of heating, how the cooling air flows affects the performance. Then I think we discussed about how the different teams are working in isolation and how they can be integrated on 3x platform. Okay, and what are the benefits in the brake systems from improved braking margin in wetting condition to various disciplines, how they can collaborate, again maybe reduce the warranty costs by predicting duty cycles and improve passenger experience by eliminating brake noise. Again, he explained what are the sample workflows available, like brake squeal. Even one of the participants asked cooling, structural durability, how systems integration also comes into the picture, sensors also. Again, I think we some of the case studies with JLR and Tata and some customers also, we as an overview we just saw, and how the ID card is there with us, and how we can explore the same, and how all this can be done with the help of KPIs for the brake performance we discussed about. So I thank you, Mr. Prakash, for the wonderful presentation, and I thank you for all the participants for the patient listening, and thank you for EDS and Dassault Systems for organizing this wonderful webinar. I hope to get new updates on similar domains soon. Thank you.
Thank you everyone for joining this, and have a good day.